Hi, folks.
Oh, perfect.
Right. So Unit 3 is Pythagoras theorem, and your objective, okay, is be able to calculate an unknown side of a right-angled triangle. Okay, that's your objective. Yes.
I think I forgot my maths book in the German class.
Right.
Do I get a? Should I just get a piece of paper?
And then copy it up.
Okay. Thank you.
Is it nine?
Okay. So we have our objective. Now here's the important thing. Right, we are only worried about today right-angled triangles. So we're talking right-angled triangles. Right? It's important that Pythagoras' theorem goes together only with right-angled triangles. You need to make that link. Right? Do you all know what right-angled triangles are?
Yeah.
Yes.
Archie?
Are they triangles with an obtuse angle? Actually, this is recorded live.
No, the triangles with the right angle.
Yeah.
Wow.
I do that, don't I? Because I'm still connected to my highlighter. Right, so basically what we need is a right angle. Right, and when we have a right angle, that's quite cool, I like that. Then we can make a triangle out of it. So can you draw yourself, using a ruler, a nice right angle triangle?
Your video is called YouTube.
Right, so right angle triangle. Okay, so we have this little symbol. If we put a square in the corner, that denotes a right angle. Okay. Now we have to know how to label a triangle. Okay, and three sides are labelled A, B, and C. Yes, Sushi.
So, is it the base and the height and the side?
That's not A, B, and C. There is base, height of this triangle, but it depends. Base and height change depending on what I decide I want to be the base. Yeah? This is not necessarily the base of my triangle. I can turn it around if I want, but we're not really worried about height and base this time, because we have certain sides. Now this side has a name, and it is called hypotenuse. And we call the hypotenuse, always the hypotenuse is always the longest side opposite the right angle, and we give that a letter, and that letter is C. The other two sides adjacent to the right angle are A and B. It doesn't matter which way round it is, okay? They just are. Now I'm going to do something. Let's see what I can.
That's so.
That's cool.
I like that. I need it to be. Oh. Need to be right on the line. Okay. Now here's the thing. So what we're going to do. Yes, Sushi.
Isn't the Pythagoras theorem is equal to
We haven't got there yet, so thank you. Yeah, it is. So let's decide where that comes from. So basically, this guy Pythagoras did a lot of investigations into triangles, specifically the one that we're talking about, the right-angled triangles, and he found something out. And what he found out was, if you, I don't know if this will work, if you put a square on the two shorter sides of a triangle, alright? So if you put a square, are they actually squares?
Yeah, that's.
Okay, that's a square.
No,
That's not a square. If you put a square on the two shorter sides of your triangle, I'm kind of
yes,
guessing.
no.
That, do you think?
No, it's a bit of.
One more.
Less.
Up. There.
No, a bit more.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It was actually right. 4.
Kian.
It does. It looks right. Doesn't it?
Mr. Boss, I noticed technique.
Yeah, me too.
Yeah, good. So, 1, 2, 3, 4, 5, 6. Okay, there's my square. Right. So, you draw two squares. Alright. Now, what he found out was, if you find the area of those two squares and add them together, you will get the same area as if you take a square. I'm going to have to look at this one on this side. Now this is going to be harder, but you get the idea. I did, yeah. I should have said really, shouldn't I? But
I don't
so
have time. I don't have space to do it. So.
You don't have time left.
you do it in whatever way you manage. It's rough, and mine's a bit rubbish as well, isn't it? That is pretty poor, but you get the idea.
Okay.
Daniel?
I have a different and faster technique to do this.
Do what?
So, for example, you have
Draw
the
a square.
triangle. You would double it, so you would like mirror fold it towards the other side. You would find out the area of that rectangle, because that would be a rectangle now, and then you would half it, and then you have the answer. That's the area.
The area of triangle. I'm not talking area of triangle.
You want the area of the square.
Yeah, what we're trying to find, do you remember what we're trying to find? We're trying to find lengths. Now, I've changed my C. So A, B, and C are the lengths of the triangle. Okay? Don't forget, that's what it's all about. Now, if I've got the length of the triangle A, and this is a square, the sides of the square are also A. Okay? And this triangle is B, oh sorry, this square is B. This square is C.
Wait, hold on.
So what we are looking at is the areas of those squares. So Pythagoras found out if you work out the area of that square, what is the area of that square? Just in algebraic terms. If side is A, the area is
4.
no, not 4A.
3.
A times A. We did A times A, which we write as
A squared.
A squared. Okay. And B is B times B, which is
B
B squared. And the area of this square is C times C, which is
C squared.
C squared. So remember, it's area of the squares that we're talking about when we do that. So it's not the area of the triangle in the middle, it's the area of the squares that are created. Okay? So Pythagoras found that if you take the area of two squares and you add those two values together, you get the area of the big square. Okay? So that led him to write his theorem, which states that C squared equals A squared plus B squared. Now that, of course, relies on the fact that C always has to be the longest side, because that makes the biggest square. Has to be the one opposite the right angle. And it only works for right-angled triangles as well, because
that makes sense.
yeah, exactly. If you make a different triangle without a right angle in it,
One could be like that.
exactly. You make one longer and whatever. Okay. So that's it. That's Pythagoras' theorem. We've just got to figure out how we use it now, right? So we can find the areas of squares. Brilliant. But what do we actually want to do is, looking back at our objective, we want to be able to calculate a side of a triangle. Right? And we don't necessarily want to have to draw all these squares. That was Pythagoras. He did that. We don't want to do it. Okay. So, let's have a look at a problem, right, that we can look at into solving. Okay. So if we have, we're going to change it slightly to show you that the triangle doesn't always have to be the normal way around. Okay. So if I've got this triangle, this side is, call it A if you like. This side is therefore B. This side is
C.
What's the name of that side?
Hypotenuse.
The hypotenuse. Yeah.
What happens if the two longer sides are the same length?
The two longest and two shorter ones.
Like if it's an isosceles triangle. Oh yeah, okay, it's not.
Yeah, no, you can't have, yeah, remember it only works with a right angle. I know what you mean, if you've got an isosceles triangle. But you can have an isosceles right angle triangle, but if I make A and B the same length, which we will look at, C will still be longer. Right? So let's say that A is 3 and B is 4. Let's write this down. Let's say A is 3, let's say centimetres, B is 4. So we're not going to draw the squares, no. We're not going to draw the squares on it. We don't need to. We're going now. So the question is, what is C? Okay, I'm going to call C because it's an unknown. I'm going to actually say X. So A, B, and C is not necessarily used apart from when you state Pythagoras' theorem. So we can now write certain things. Now, the length of the side is 3, but remember, Pythagoras wasn't about the length of the side, it was about the area of the square on this side. So we know that if we square 3, okay, and we add it to the square of 4, we will get the square of x. So we'll do that. We get 9 plus 16, and that equals x squared. Therefore, 25 equals x squared, which means the square root of 25 equals x, which in this case is 5. And that leads us to one of the most well-known right-angled triangles, the 3, 4, 5 triangle. Right? The Egyptians used it.
The Babylonians.
The Babylonians, they used it because what they did was they had a piece of rope. Okay? They had a piece of rope, however long that rope was, and they tied knots in it. Okay? They tied, I think, what was it? 12 knots. And then what they knew was, if they got 3 people, or stakes in the ground, and they spaced it, so there was a stake, and they went 3 spaces, put another stake, pulled it tight, and wrapped it round, they always got a right angle. And that's how they managed to make buildings with a right angle, you know, without having proper set squares and things. So just a bit of rope, 3, 4, and 5, made into a 12. Pull it tight, and that's how it works. So that's a special one. Others are 6, 8, and 10.
Yeah.
Double every side. Okay? So we can show, actually, if I said to you, show that this triangle, really rough sketch, is right angle. Yes, please, not as rough as that. If I said to you, show that 6, 8, 10 is a right angle triangle, right, how would you go about proving that? Amal?
So 6 squared plus 8 squared is equal to x squared, and then 36 plus 48, no 64, yeah, is equal to x squared, and then 100 is equal to x squared, and then the square root of 100 is equal to x, and then
So x equals the 10. So because you've shown that, now if we had an answer down here that was not the same as 10, then we'd know it wasn't right angle. Okay? If it doesn't work in Pythagoras' theorem, we don't have a right angle triangle. Okay? Yeah. And then I'll give you another couple of questions to do. This time, however, you may well need your calculator.
Rough sketch though.
Rough sketch. You can do it with a ruler.
It's still recording.
Yeah.
Dun, dun, dun.
Hello, I'm Sushi.
Hello,
Please subscribe and like this video.
Everyone subscribe to the Sugar and Lord Bolt.
Spend me on this channel.
You're Lord Bolt. Yeah. And you're Sugar.
Oh yeah.
And this is a mug.
A mug.
A mug.
and this is sushi. And